Hi everyone, I'm here, Ishan with Fun FTC, and we're here interviewing Team 15772, the Brady Goats from New Hampshire. They're a high school team and they've got a really cool robot here today. Let's go ahead and dive right into the robot.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting Fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or career that supports you being in FIRST, check out careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com and let's get your team scheduled to be on First Updates Now.
So you were showing me some of the cool things about your intake. Do you want to show me a little bit more about how you were able to get the intake to pick up a lot of rings?
Yeah, sure. Yeah. So on the front of our intake, we have two angled pieces. We call them the snowplows that start inside the intake, so inside the robot, and then each one is on a servo, so that at the start of the match they can pull it out, and it makes it so that our intake is wider while still having the powered part contained within the robot, so that doesn't get damaged. And then they can also fold back so we can hit the walls and not worry about them breaking.
What material is that made out of? It looks flexible.
So it's wood with a rubber band to help it spring back into place.
Really, really cool stuff. And then you were also showing me a little bit about your hopper. Your hopper's got a lot of different linkages is what you showed me. Can you give me a little bit more detail on that?
Yeah, sure. So our hopper, where the rings come in, they stack up like a lot of other teams have. And then after they stack up, we have to get it up into our shooter. So we have a servo with a linkage to push the hopper mechanism over, and then another linkage that goes on this curved track here that brings the rings up to the height of the shooter.
Yeah, that curved rack here is really, really cool. So after they get up into that position, how do your rings shoot out? Could you show off your shooter a little bit? And it looks like you got some motors mounted at weird angles. Could you talk a little bit about that?
Sure. So we have one servo here for flicking the rings into the shooter, so it just flicks the bottom ring of the stack one at a time. So what we've actually done is we have the servo on position mode because we tried having it on continuous mode, but it wasn't accurate returning to the position that we wanted it to return to. So we have a gear ratio that allows us to set the servo to position mode. And so each ring gets flicked out one at a time into our shooter. And we have one wheel, like most teams have, one 4-inch wheel that shoots the ring into the goals. And we also have another wheel, 2-inch wheel, that feeds the ring into the shooter. But it also helps us speed up the rings so that they don't slip as much on the main shooter wheel.
Awesome. And then what motors are you using to power that? It looks like you're using like a bevel gear mechanism. Could you talk a little bit more about that?
Yeah, sure. So we have two 6,000 RPM motors, one here and one here, and both of them are mounted to this U-channel, go build a U-channel. And we have a bevel gear on each motor shaft, and then we have another shaft with a bevel gear that is connected to both motor bevel gears, and that powers our main shooter wheel as well as our 2-inch feeder wheel.
Yeah, so on your shooter, I'm also seeing a lot of like acrylic. Is that acrylic? Is that Lexan? How did you machine that?
So yeah, it is acrylic, and we have a CNC at our workshop. And so we first made it out of wood, like our snowplows and most of the other components of our robot, but we've been changing them over to acrylic as the season has progressed.
Awesome. And why did you pick acrylic for that kind of stuff?
The main reason was that it looks pretty cool, and we thought it looked cooler than the wood. And also the other reason is that when the hopper mechanism is down inside our robot, we can actually see through the shooter mechanism into the hopper to make sure all three rings stacked up correctly.
Awesome. So now I want to go into a little bit about software. What sorts of sensors do you have on the robot? I saw you had a phone camera, so you went with the expansion hub setup, it looks like. Could you talk a little bit more about the phone camera and that decision, as well as some other sensors you may have on your robot?
Sure. So we're using the phone camera with TensorFlow at the beginning of the match to detect the stack of rings. So we use that over a webcam because with the phone camera, we're very easily able to see what the camera is seeing instead of having to connect an external monitor. And then we're also using, on the wobble goal mechanism, I can bring it up. We're also using a touch sensor so that we're able to reset the limit of the wobble goal arm, so then we're not breaking the motor by going too far in one direction. And then also on the flicker, we used to be using a 3-bore encoder to be able to flick out the rings, but now that we've changed to position mode, we're not using that. And then this year, we're also using odometry. So we have 3 odometry pods. Each of them have a 3-bore encoder to detect the tracking of the robot in the field.
Awesome to see odometry really making its way into a lot of teams' places. One thing that I wanted to finally ask you about was your wobble goal mechanism. We touched a little bit on that in the sensors. Could you talk a little bit more about the mechanical aspects of it?
Yeah, so for the mechanical aspect, we have the motor at a parallel or a perpendicular angle to the actual shaft, and so we have a worm gear inside that connects here so that we didn't have to worry about having the motor like sticking in the way of the shooter. And then we also have a 3D printed piece on the front so that we can manually turn the wobble goal arm when the robot is not powered.
Awesome. Really cool stuff. You've got an awesome robot here. Best of luck to you in the competition for the rest of Ultimate Goal, and we will see you next time.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.